name is Marita Hefter, and I'm a postdoc at Aarhus University at the Department of Food Science. And today I will show you our experiment with compost in lettuce production. So did you know that compost is very beneficial in many ways? It is a means to recycle waste products, and through composting you can get a very stable product. So you get a CN ratio of around 15, which means that once you apply it to the soil, it will not cause immobilization. Composting also causes the destruction of weed seeds and pathogens, so it's a safe product to use. It can be used both in the fields, but also as a potting medium in pots. And it's good as a slow nutrient release, to have a background nutrient release. And when applying compost, you can increase the cation exchange capacity of soils. The cation exchange capacity is important to bind and to release nutrients. So if soil has a high cation exchange capacity, it's very good for plants for nutrient uptake. Moreover, compost can improve the soil structure simply by adding it to the soil, and it also improves the water holding capacity. And especially in terms of water holding capacity, this experiment is aimed to test whether compost applied to soil can improve water holding capacity and as a result plant response. So here we tested, in this trial, we tested 5 different composts from 4 different countries in the North Sea region under the project Soilcom. And it is, I will introduce you to the types of compost. So here we have one that is from Holland. It is made of wood, leaves and green waste. A very fine compost. The second one is similarly made of wood, leaves and green waste, but it's from Denmark. And it is produced on a windrow, on a turned windrow. This is where they have the pile and then they turn it 3 times. Another compost we have from Belgium. It is made from plant residues, leaves, hedge trimmings and mowed grass. And it's made on an aerated static pile, which means it has very controlled conditions and the pile is aerated from the bottom, but it's not turned. In a similar way, the compost from Germany in Hamburg was made on an aeratic pile, but it is made from different materials. So this one we used 95% digested organic household waste and then 5% garden waste. The other compost from Denmark is made on a farm, more on a farm scale compost, a smaller scale, where they use lots of vegetable residues, grass, clover, straw, and twigs. And they turn the pile 15 to 20 times during 8 weeks, so it's a very intense composting process. So in all the pots we have these different types of compost that were added to sandy soil. So this is the sandy soil we collected from a field here in Denmark. And sandy soil is very prone to drought problems, so that's why we use this in this trial. What we did is that we added the compost to the soils at a ratio of 30 tons per hectare. And then we left the pots to stay for 2 weeks so it can start some process. Afterwards, we filled it up with water to field capacity. And while filling up the pots to field capacity, we could already see that the ones that didn't have compost had a little bit of water running down the pots into this tray, whereas the pots with compost were better at holding the water that we applied. Then we've transplanted the lettuce, and it was growing, and now 2 weeks ago we initiated the drought stress period. This is where we stopped irrigation in half of the treatments, and you can already see on this plant that it is looking very sad. The leaves are very almost wilted, so they don't have a lot of water, so they are highly stressed, and we are comparing these plants with the optimal irrigation, and we measure photosynthesis, but also stomatal opening, so whether or how much the plant opens the stomata. As you know, when the plant is stressed, it will tend to close the stomata, and then therefore it will affect the photosynthesis rate. Apart from these measurements, we will also measure the soil and the soil microorganisms, how they are affected by compost, but these measures will only be taken once we terminate this experiment. A quite interesting method that we use to measure root growth is cutting a window into the pot. And you can see here that you can open this window and you can find the roots there. And we measure it by using this window that we attach onto this root window, and then we count how many times the roots intersect with the lines that we draw. And as a preview, I will show you the results we obtained from these root countings. We scraped off the surface before initiation of the drought treatment. So the results you see here is from the start of the drought treatment. And you can see in orange the drought treatments of the different types of compost, and in blue is the optimal irrigation. And what you see is that drought, of course, reduced new root growth in all treatments, but most pronounced was the finding that under the control, so where we only have the soil, we have no new root tips coming up at all, whereas in all the compost treatments, we have even new roots coming at drought conditions, which already indicates the beneficial effect of compost. This is so much from my side. I hope you enjoyed this movie.